Hello, my name is Nur Shuhada and I will present about the introduction. Company background. SKHPA Consulting Engineer was established in 1988 and has evolved into one of the leading engineering consulting companies in the areas of engineering design, project management, supervision, quality assurance, and consulting services. The company mission is to undertake in the engineering and construction business with a focus on becoming the cost leadership while excellence in every aspect to meet customers' stringent requirements regarding quality, on-time delivery, safety, and environmental concerns. As we can see in the figure 1 here is the company logo of our company. Project background. SKHPA Consultant is main civil and structural consultant that has been appointed to construct a bridge for pedestrians to cross over Jalan Keluang in Yutesh main campus. Our company is in charge of the bridge design and layout as well as its safety. The consulting agency will determine all the structures parameters including the bridge dimension and the materials to be used in the construction of this pedestrian bridge. Our company will finish the pedestrian bridge construction on schedule as specified in the contract. Project location is this pedestrian bridge construction project was proposed beside the Jalan Keluang in Parit Raja, which located near Yutesh main campus. As you can see in the figure 2 here is the location of our bridge construction. Pedestrian bridge. A pedestrian bridge is a bridge that is specifically intended for pedestrians. It is usually placed across roads to allow people to safely cross without slowing down automobiles. The majority of the footbridge has guardrails to prevent users from falling. As for our country developed, it is critical to standardize sustainable footbridge designs to ensure public user safety. This is the detail of our structural design, with our proposed pedestrian bridge length is 21 meter and our proposed pedestrian bridge width is 1.6 meter. The permanent load is 17.9 kN per meter and variable load is 6.8 kN per meter, short-term losses 10% and long-term losses 20%.
My name is Ms. Day bin Abdul Kadir. So, the modeling and the structural analysis of the pedestrian bridge was carried out with the help of the STAT Pro V8i software in this project. So, this is the modeling of the proposed pedestrian bridge design, and this is the front elevation of the pedestrian bridge design, and this is the three-dimensional view of the pedestrian bridge design. A box girder, which the main beams comprise girders in the shape of a hollow box, was used to design for this pedestrian bridge project. Several rectangular sections were used to design this box girder. The summary of the section properties subjected were shown as below. The actions applied in the software where the total GK and QK are 17.9 kN per meter and 6.8 kN per meter. Based on the STAT Pro analysis and design, the proposed design for the pedestrian bridge is adequate and passed.
The 3D layout of the proposed pedestrian bridge was as in this video. This 3D layout was as a visualization of the pedestrian bridge after the construction has been done. SketchUp software was used in this project to portray the 3D modeling for the pedestrian bridge.
Okay, good morning, Mr. Ko. My name is Cai Zhuanzi. Now I want to present about the loading of our project. Okay, the unit weight of concrete is about 24 kN per meter cube, and the floor is about 2.4, finisher is about 1.2, and the railing, which is the handling, is about 0.73, roof is about 0.024, and the live load we use 6.8 kN per meter.
Good day to Mr. Ko. My name is Wong Wei Cheng, and now I'm going to present my part in design of prestressed member in fracture. So basically, for design the box girder in the pedestrian bridge, we need to determine the section property first. And from the figure as shown below, the length of the top part is 1600 mm and for the bottom part is 1300 mm. And we need to calculate the area for the box girder, and the area calculated are 468,000 mm². And next we need to determine the moment of inertia by using the formula, and then we will get the modulus of section ZT and ZB. Basically, the ZT and ZB, we need to determine the YT and YB also. For the YT from the natural axis is 285 mm, and for YB is 325 mm. Next, we need to calculate the moment for the self-weight and also the moment for the total service load. And this is the MI value and also the MS value. And next, we need to check for the section modulus based on the inequality of 9.3a and 9.3b. And we can determine whether our proposed size is passed or not. Basically, from the calculated value, you can see that the design is passed and able to satisfy the ultimate limit state. Next, for construct the Magnum diagram, we need to consider 4 inequality, which are 9.5a to 9.5d. And this is the design detail that we'll use in our design. And from the inequality, we can plot the Magnum diagram graph. And basically, this is the shaded region. And we can observe that the 200 mm eccentricity will lie on the shaded area. And we can see the limit is controlled by the inequality of 9.5b and also 9.5d. And therefore, from the inequality, we get the pre-stressing force must less than 5,891 kN, and the limit must be at least 4,780.8 kN. Therefore, we will consider this is the limit. Next, for the construct the cable zone, we need to classify according to the different distance from the mixed span, and we construct the table in our project. Basically, we can observe the MI and NS will continuously increase as the distance increase, and the eccentricity will also change accordingly. And from the inequality, we use 9.6b and 9.6d to have the result. And from the table of result, we can construct the cable profile, and we provide the 7 wire and 15.2 mm diameter, and we assume the initial precess is 70%, and therefore we provide 23 wires. That's all for me. Thank you.
Ultimate moment of resistance. Okay, first of all, this is our specification. Our span is about 21 meter and GK is about 18.2, QK is about 6.8, and then we check the ultimate moment. So the checking MU is greater than the MED, so the moment is passed. So this is the detailing of our post girder. Okay, this is the graph we plot to know the checking the ultimate moment. Okay, next we checking the ultimate shear of our post girder. Okay, first we draw the BMD as SFD. We use the table to know the MX and the VX, and then check the maximum allowable shear stress. Okay, the Vmax is greater than the V, so the shear is passed. And then this is our shear diagram, shear force diagram, SFD. And then we also plot our BMD. Okay, this is the BMD. So this is the section crack and this is the section uncracked. Okay, then we calculate the VCR using this table. And then we also calculate the spacing. Spacing we use the 200 mm spacing. And then this is our detailing. This is YB, YT, and all the detailing. Okay, that's all for my presentation. Thank you.
So for diffraction in our bridge design, basically we consider short-term diffraction, and the short-term diffraction are divided into the two stages, which are at transfer stage and also at service stage. For at transfer stage is due to the preset force plus the self-weight, whereas for the at service stage are due to the preset force plus the service load. And we need to calculate the diffraction due to the preset force and also due to vertical load. And from the calculated value, if the value obtained is negative, means that it will deflect outward, and if we obtain the positive value, then means that it will deflect downward. And we need to check the resultant diffraction either at transfer or at service is greater or lesser than the allowable diffraction. Therefore, based on the result, you can see that lesser than the allowable limit, therefore the diffraction is okay. Next, for the en bloc design, we design for the triplet anchorage with the jacking force of 1000 kN. For the maximum bursting force is 690 kN, and therefore we will calculate the AS required and we provide the link. Basically, this is the detailing for the en bloc, and then we provide 4010 for the individual prism, and for overall prism we provide 9016. That's all for me. Thank you.
For the conclusion, the overall outcomes according to manual calculation is satisfactory. The analysis from the StatPro software confirms that the design system has no errors. To summarize, the primary goal of this project is to build a high-quality bridge at a minimal cost. Concepts are based on modular units made from steel board girders, which are presented in this report. The design, bridge size, materials used, procedures, and specification process were determined to consider, monitor, and assess the bridge in developed area with significant traffic when constructing this footbridge. Thank you.